ln x. Natural log of x. So the derivative of x natural log x minus x is ln x. I've had students in the past that look at this right here, and they look at that. That's a lowercase l, but some people think it's an I, and they say INX. LNX comes from natural log. The way French would say that would be logarithmic naturel, something like that, backwards. So that's why it's ln and not NL. It makes more sense in English to be NL, right, natural log. But it's a French thing, all right? All right, let's move on. How about number 4? So we have y equals, no, it's f of x again. F of x equals natural log of sine squared x. So what rule or rules do you see here? Chain rule, right? If it's chain rule, then what's the last thing happening? What's the last thing that would happen? The outside function. The ln, right? Then go in, what would be the next thing that happens? Squared, and then inside that, the sine. So we have to remember that squared on the sine means that you would, like if you started by trying to plug in an x, the first thing you do is you take sine of it, then you'd square it, then you would take natural log. So the backwards, doing that in reverse order would be natural log, then square, then sine, right? So when I do my chain rule here, I first say, what is the derivative of natural log of some junk? Natural log of junk now. It's not natural log of x, it's natural log of junk. So do I need to go flip back or no? It's 1 over the junk, which here is what? Sine squared x times the derivative of the junk now, right? The derivative of the junk. But what's the derivative of the junk? So now you have to go inside, the natural log's gone. What's derivative of sine x squared? So what's the derivative of junk squared? 2 sine x to the first power, but I don't need to put first power, right? So I've taken care of the natural log when I did this step. I took care of the squared part when I did this differentiation. And now I need times the derivative of what? The sine, which is cosine x. Does that make sense? And clean it all up. I have 2 sine x cosine x over sine squared x. And you might recognize 2 sine x cosine x from pre-cal. What's 2 sine x cosine x? It's a double angle identity. It's sine 2x. Not sine squared x, sine 2x. I didn't have to do that, but it looks a little cleaner, doesn't it? Questions? Sure? How about number 8? Or, you know what? Yeah, let's do 8. So f of x equals log base 5 of x times e to the x. All right, so we have chain rule here, right? We have log base 5 of junk. The junk inside is a what? It's going to turn out to be a what when we take its derivative? That's right, product. It's x times e to the x, right? So that's going to be a product rule. But I first need to figure out what's the derivative of log base 5 of something. What's the derivative of log base 5 of something? 1 over the junk, right, the something. And then this is important right here. ln 5. Good. Now, natural log of 5 is just a number, okay? Think of it as a constant. It's like 2, but it's not 2. It's natural log of 5, whatever the hell that is on your calculator. Okay, so I have 1 over x e to the x times natural log 5. That's the derivative of log base 5 of some junk. Times, chain rule, go inside. What's the derivative of what's inside? That's a product rule, right? So I have derivative of the first one, which would be 1 times e to the x plus the derivative of e to the x, which is itself times x. Which is e to the x plus e to the xx all over x e to the x times natural log 5. Kind of running out of room there. I just took everything in parentheses, moved it up to the numerator, just cleaned it up a little bit. There's something else we could do here that I'm sure the book does. Couldn't you factor an e to the x out of the numerator? They both have e to the x in them, right? So you can make that 1 plus x. And then on the bottom you have x times e to the x times natural log 5. So what can you do now? Cancel the e to the x. Because this e to the x cancel because there's multiplication on the bottom, right? So you can cancel through. Can you all see that all right back there? So I'm left with 1 plus x over x times natural log 5. You'll notice, maybe you won't notice, I don't know. My pages are going to be coming to an end here. I'm trying to make it where what I'm writing on will print out better for y'all. You know how sometimes when you print out the stuff I do here, it like carries on to the next page, if you've noticed that? I'm making it so it should print off nice and even now. Okay, questions on that one? Want to try and get, oh, this one looks good. Capital H of z equals natural log of the square root of a squared minus z squared over a squared plus z squared. So my variable in this problem is z. A is a what? Is a constant. A is a constant. What rule do you see happening here? Chain. What would the last thing happening be? ln would be the last thing. Okay, what would be the next thing? Square root and then quotient rule, right? So I could do it that way. However, would you agree that this is the same thing? I'm going to save myself a lot of work here. Isn't the square root the same as raising it to the 1/2? Yes? And then there's a property, because this was mentioned, I think, in 3.1 or 3.2. In 3.2. There's a property of logs that says this, and I'll just write it down. Natural log of x to the n equals n natural log x. That's something that in college algebra hopefully you saw, that if you ever had natural log of something to a power, that power could come out in front. Do you all remember that? A very nice property of logs. So as an example, natural log of x cubed is the same as 3 natural log x. So for us, the natural log of all that junk to the 1/2, what can I do with that 1/2? Pull it out front. And that's just going to make our differentiation a little bit easier. The 1/2 comes out. Now we have natural log. Then we have the quotient rule in the natural log. But do you see that we're not going to have to worry about the square root in our differentiation? Like it's no longer part of our chain rule. It's really a 1/2 sitting out in front, which is really, really good. Okay, I think now I'm ready for the derivative. The derivative, h prime of z, will be equal to, well, the 1/2 is a constant, so I'm just going to leave it 1/2, times, what's the derivative of natural log of some junk? 1 over the junk, right? 1 over that junk. Okay, times what? The quotient rule on the junk, right? Quotient rule on the junk. So here comes my quotient rule on the junk. I mean, I'm kind of like already setting up my quotient rule right here. So remember that what we're trying to take derivative of, I just highlighted in yellow, is the quotient rule on that. Treating a like a what? Constant, and z like the variable. So let's do quotient rule. Derivative of the top. What's the derivative of the top? What's the derivative of a squared? 0. 0. Because a is a constant. So that may as well be 4 squared. And what's 4 squared? 16. What's derivative of 16? 0. So we treat the a like a constant. The derivative of it will be 0. A squared. Is that all right or not? Does everyone understand, by going back and looking at the problem, the fact that the z is in there like that tells you what the variable is. And I told you previously that we usually treat a, b, c, and d like constants. Okay, so the derivative of a squared is 0, minus what's the derivative of z squared with respect to z? Just 2z, right? 2z. So I'm going to get a minus 2z. That's the derivative of the top, right? Times the bottom. Okay, minus the derivative of the bottom. What's the derivative of the bottom? 2z times the top all over the bottom squared. Now I am going to clean this up. What about this? What's 1 over a fraction? It just flips the fraction over, doesn't it? Okay, so this becomes, I'll just leave the 1/2 out here for now. This becomes a squared plus z squared over a squared minus z squared times, now I'd like to distribute the negative 2z through, and I'd like to distribute the negative 2z through again. So I should get negative 2za squared minus 2z cubed minus 2za squared plus 2z cubed. Just be careful with your signs there. All over a squared plus z squared squared. We do get cancellation, right? The 2z cubes are gone. How many za squareds do I have? Negative 4, right? Negative 4.